All right. Shh, 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 shh. Guys, please hush. All right. So solving exponential equations using logarithms. So this method that I'm about to show you will work for any exponential equation. All right. The light basis method only works for very specific scenarios, but logarithm method works for any exponential equation. So earlier, again, we talked about the method of common bases. That's what we learned on Wednesday. Now, it's quite limited because it requires two sides of the equation to be expressed using the same base. Now, the more generalized method is using the third logarithm law and calculators. So that's why I say you need a calculator, because a lot of this is going to be going in your calculator. But we're not using Desmos because we're not using it from a graphing standpoint. It's just going to be a lot of stuff that you input in your calculator to get an answer. So before we actually talk about the logarithm approach, we first need to talk about the third logarithm law. And all it states is that if you have a log of b where a is raised to a power of x, we can take that exponent and bring it down to the front of the log to be multiplied to the log. All right. So it can turn into x times log b of a. So for example, let's say that I had log 3 of x squared. This would be the same thing if I bring this squared down to the front of 2 log 3 of x. It's just a property of logs that we utilize a lot with this method. Now, the first exercise is actually one that we can solve with common base. So we're going to review the common base method first, but then I'm going to show you how to do it with a logarithm. All right. So the equation is 4 to the x power is equal to 8. So we're going to do the common base method first. So this is review from Wednesday. So what is my first step when I'm doing common base? So what is my first step when I'm doing common base? Right, we need to find a base that would raise two different powers will give us 4 and 8. What is the common base? 2. So I'm going to rewrite these in terms of base of 2. So I have 2, and we're going to do parentheses with the next power. It's equal to 2 to some power. So 2 to the what power is 4? 2. 2 to the what power is 8? 3. Now, remember, before we can eliminate the bases, we first got to do this power rule right here. So we got to multiply the x to the 2. So this now becomes 2 to the 2x is equal to 2 cubed. Now, what happens once we get the like bases and the power rules all done? What can we do? The bases are gone, and we bring down the exponents to make a linear equation. So I have 2x is equal to 3. Now, I just have to solve for x now. What's my last step for x? Divide it by 2. So x is equal to 3/2. Now, that was the method of common bases, which I will say, if it's obvious that you can use a common base, use a common base, because to be honest, it's easier. But again, it's not always possible to do common base. In fact, 9 times out of 10, you can't do common base. All right. But you can solve any exponential with the logarithm approach. Now, whenever we do the logarithm approach, the log that we're going to use exclusively is the common log. So remember, the common log is a logarithm with a base of 10, and you just see it as log, and there's no little b value, so log of x. Now, I will also mention this because when I was in school, the way I learned it is instead of using common log, we always use the natural log. So we use ln of x, but to be perfectly honest, it doesn't matter. You can use any type of log of any given base. All right. So natural log is a base of e, common log is a base of 10. You could use log with a base of 3. You can use log with a base of 100. It doesn't matter. All right. The only reason we use one of these two is because, first off, our calculator has those nice buttons on there, so we don't have to do a lot of math and then scroll down and everything. Second off, they are just the more specialized ones that you just see a lot in math. But regardless of which one we use, we should still get the same answer. All right. Now, for this class, again, I'm going to use the common log just because that's how you'll see it a lot on the EOC. But just note that you could also use natural log because you may see that in Math 4 if you have to take it. All right. So we're using common log. So here's how we do the logarithm approach. So I'm going to rewrite the equation. Now, usually with the logarithm approach, the very first thing that you have to do is get the base of the exponential by itself. So is the base of the exponential by itself? So in other words, the base is the number attached to the exponent. So nothing's being added or subtracted to it outside of it, nothing's being multiplied or divided to it. So is that 4x by itself on one side of the equation? Yes. So once that happens, we can take the common log of both sides. So you're taking the common log of both sides. Now, remember, this is just like any equation. Whatever you do to one side, you have to do the other. So the reason that we're taking a logarithm is because once we take a log of both sides, we want to get this x out of the exponent. All right. So by taking this log, we can now use that third logarithm law, which was above, and bring that x to the front of the log. So it's out of the exponent. So that's our next step. We're going to bring that x out of the exponent. So we now have x log of 4 is equal to log of 8. Now, even though this looks like it is the most complicated thing in the world, guess what? This is almost the same thing as 2x is equal to some number. Because log of 4 is a number. All right, don't believe me? Well, if I put this in my calculator, I'm going to hit the log button, type in 4. Do I, in fact, get a number? Yes. Log of 4 is a number. So we can treat it like a number being multiplied to x. So if this is just a number, log of 4 is just a number. If that's a number being multiplied to x, which by the way, log of 8 is also a number, a log of a number is a number. So since that log of 4 is being multiplied to the x, how do you think I'm going to get the x by itself? So what would you do if it was like this? You would divide by 2, right? So same thing pretty much, just with logs. So what do you think you're going to do? What you just told me that you do for the other one? You divide it. So we're going to divide both sides by the log of 4. So that means x is equal to the log of 8 divided by the log of 4. Now, this is where your calculator comes in. So we're going to take this expression and we're going to plug it into our calculator and get a number. So in your calculator, I'm going to type in log of 8. Make sure that parenthesis is closed on the log of 8. Otherwise, you'll screw it up. And then divide it by the log of 4. So log of 8 divided by log of 4. I know it's kind of messed up because of the way the projector is placing, but try your best. So everyone should be putting that in their calculator right now. You need to practice this. So log of 8 divided by log of 4. If we hit enter, what is it? 1.5. Now, is that not the same answer that we got for the method of common bases? Yes, because if we change 1.5 to a fraction, it's 3/2. All right. So x is equal to 1.5, which we know is also equal to 3/2. I mean, I'm putting it just because more often than not, when you do a logarithm using log method, you're going to end up rounding anyway. So I'm just saying that, like, it's not always going to turn to a fraction. But in this case, it does because it was a common base. So typically how it works is if you can make a common base, you will get a pretty number. But if you can't, it's going to be ugly. Also, if you don't know where the log key is, it's to the left of the 7. All right, any questions on how to put that into the calculator? All right. All right, so let's try some where we know for a fact. So let's try some where we know for a absolute fact that they do not have common bases. All right. Now, for all of these, we're going to round our answers to the nearest hundredth. So that's 2 decimal places. So look at letter A. First off, let's just ask ourselves, does 5 and 18 have a common base? No. If there's no possible number that will give 5 and 8, that will be raised to a power to give 5 and 18. It's impossible. So we have to go ahead and use the log method. So first off, the number connected to the exponent is the 5. Is that base by itself? So nothing's being added, subtracted, multiplied, or divided to it. Is that true? Yes. So if that's true, we can go ahead and take that log of both sides. Now, I'm writing it up high just for lack of space, but it's really going to look like this. Log of 5 to the x is equal to log of 18. So I took the logs of both sides. Now, what's my next step? Take the x, move it to the front of the log. So we're taking the x out of the exponent. So I have x is equal to, oops, nope, jump the gun. X log of 5 is equal to the log of 18. What's my next step? Divide by log of 5. That's gone. So x is equal to log of 18 divided by log of 5. Now, this right here is our exact answer. All right. So if we wanted it to be perfectly exact, we would just leave it like this. So this is our exact answer. But more often than not, you're going to put that in your calculator and just round. So take a minute, put that expression into your calculator. So you're doing log of 18 divided by log of 5. Say it again. Hundredths. So 2 decimal places. So you're rounding to the nearest hundredth, so 2 decimal places. So I should see everyone putting that in their calculator.
I think the batteries are dead. Just put it on my desk.
All right, y'all put it in? So what is x approximately? So I want it to 2 decimal places. 1.80. Or just 1.8. Now, does anyone know why I use a squiggle equal sign? It's approximate. So in math, a squiggle equal sign means approximately. Yes?
So they were not like this test. Yes.
No, I mean, like, I just say get into the habit of it, just because knowing that notation is good to know. But if you just put equal, it won't, like, I'm not that big of a stickler, but just note that, like, that's how you would properly write it. All right, so that's your approximate answer. So take a minute, try letter C on your own. So you're trying letter C on your own. So I'll give you about 2 or 3 minutes. So I'll leave this one up just for reference. So you're trying letter C on your own. So not B, guys, letter C, not B.
Yeah.
Ladies, shh.
You did letter B. So that's correct for B, but I went C. That is correct for B, so do that same method but for C too.
Okay.
I did it once for answer. It's high. So it's
Yes, but you should
Oh, we were only supposed to see.
Hey, you want to try B?
I did B.
I mean, you want to try B? Just C. But you know what? You have more practice. All right, guys, we're gonna do 1 more minute. Looks like most of y'all are. Well.
But it's like basically, you just take this. Is it the simplest thing? You would divide it.
Here is the farm. Just up the farm. Yes. Just on farm. So right here, the curve is.
Yes.
Okay.
No, you should just notice the. I'm trying.
It's just. All right.
Let's come back together. So, walking around the room. Good job, guys. As I was walking around the room, most of you guys were on the right track or you got it correct. So, let's go with Briley. What is my first step for solving letter C? Ladies. Shh. Not yet. Before we can move the X, we first got to do what? So we can't move the X in the front just yet because we have to do what first? Right, take the log of both sides. All right. So since the base is by itself, I can take the log of both sides. So this will be log of 2 to the x power. Group 2, stop talking. Equals the log of 1560. Now we can move the x to the front. So this will be x log of 2 is equal to log of 1560. So what is my next step? Let's go with Reagan. Right, divide both sides by, oops. So we divide both sides by the log of 2. So x is equal to the log of 1560. Guys, please stop talking. By the log of 2. Now, after that, it's just putting it into your calculator and rounding to 2 decimal places. So what did you get for your answer when you put it in your calculator? Let's go, Hunter. Good. So you should have gone approximately 10.61. So good job. Now, if you were like in the 10.6 area, you just rounded it like to maybe 1 decimal place instead of 2 or 3 decimal places instead of 2, I wouldn't count it wrong. I'm not a big stickler on that. Like if it said to round to the 100th, but you rounded it to 3 decimal places, if it was on your test, I don't care. However, if it's in your Delta math, you got to round it the way it's supposed to be rounded. Otherwise, they will count it wrong. All right, so just something to be careful about. All right. Okay, so those were really, really, really easy ones. Those were easy ones. So now we're going to look at some harder ones. But there's not much. It's just like one extra step. All right. So let's look at letters, guys. So let's look at letter A on the next example. Now, first off, let's ask ourselves, is the base by itself? Technically it is, because the plus 3 is in the exponent, so it doesn't matter. The only time it's not by itself is if that plus 3 is down here, outside the exponent. So we can go ahead and take the log of both sides. So I have log of 6x plus 3 is equal to log of 50. Now, our next step is to bring the exponent down to the front. And what I mean by the exponent, I mean all of the exponents. So we're bringing that entire x plus 3 to the front. Now, this is where using parentheses is going to help you out a lot because it'll help you see it better. So I'm going to keep x plus 3 in parentheses. And then it's going to be followed by log of 6. So this is x plus 3 times log of 6 is equal to log of 50. Now, I want to get the logs on one side of the equation. All right, so I want to get both logs on the same side of the equation. So how can I break apart the x plus 3 from the log of 6? So I want the x plus 3 by itself. So how do I get rid of the log? What have we been doing? Dividing. This is technically still multiplying. That's why I put it in parentheses. All right. So it's technically still multiplication because it's just parentheses and there's a number written right next to it. Because remember, log of 6 is a number. So we're going to divide by log of 6. So I have x plus 3 is equal to log of 50 divided by the log of 6. Now, usually by here we're done. However, is my x by itself yet? No. So what do you think the last thing I'm going to do is? Subtract 3. Now, when I subtract 3, I'm subtracting 3 to all of that. All right. So this would be x is equal to, and I'm going to leave this in parentheses, log of 50 divided by log of 6 and a big minus 3 on the outside. Now, even though this looks like it crawled out of the gates of Hades, all right, it's still just a number. This entire expression will still just give you a number, all right? It's just ugly. So you got to be really careful when you put this in your calculator. My suggestion is, so I want everyone to watch me real quick. So my suggestion is when you're doing this in your calculator, do the log divided by the log first. So I'm going to do log of, what was it, 50? Divided by the log of 6. I'm going to do that first and get an answer. Then, all I'm going to do is after that, I'm just going to flat out hit minus 3. Because what happens is that your calculator saves that previous answer. All right? So I want to be as exact as possible. So my calculator saved that previous answer, so it's subtracting that answer by 3. So my actual answer is negative 0.82 if I round to the nearest hundredth. So it still goes in your calculator, but you just have to be really careful because there's more than one operation now. I would not even recommend trying to put all of it in your calculator at once. All right, because if you do that, you have to be doing a lot of parentheses, and if you misplace a parenthesis or if you don't put parentheses, it's going to screw it up. All right, so my recommendation, do this first, get that answer, then subtract the 3. All right, any questions on that one? All right, let's look at letter B. So, this one is still slightly more on the difficult side. So this has 2 extra steps instead of just 1. Now, just because it's hard to see, this is technically minus 5. So it's x over 2 minus 5 in the exponent. Now, is that base by itself on the left side? Is everything operation-wise, is that all in the exponent? Yes. So since it's all in the exponent, technically that base is by itself. So what I'm going to have to do is take the log of both sides. So this will be log of 1.03 all raised to, and I'm going to put this in parentheses, x over 2 minus 5, and it's equal to the log of 2. Now, what will be my next step here? So what's my next step? Bring the exponent to that front. So we can't even touch any of the other operations until we bring the exponent to the front. All right. Otherwise, the whole point of using logs to begin with is to get the exponent out of the exponent. All right. So in other words, get the x values out of the exponent so we can solve for x properly. So this would be, and remember, keep it in parentheses, x over 2 minus 5 log of 1.03 is equal to the log of 2. Now, what's my next step? Now we can divide by the log of 1.03. Because technically this log is multiplying to this entire expression, and we want to get this expression by itself so we can properly solve for x. So we're dividing both sides by the log of 1.03. So this now becomes, I can take it out of parentheses now since the logs are gone, x over 2 minus 5 is equal to log of 2 over log of 1.03. All right, now, still not done yet because I got to get the x by itself. So what's my next step for getting the x by itself? Add 5. So I'm going to add 5 to both sides. And make sure you put that whole log over log in parentheses so you know that it stays together. And we're adding 5 to all of it. So this will be x over 2 is equal to log of 2 over log of 1.03 plus 5. Now, technically x is being divided by 2. So how do I get rid of the dividing by 2? We multiply both sides by 2. Now, just like with adding the 5 to everything, we're multiplying the 2 to everything. So we're doing another set of parentheses. So that goes away. I'm going to write it over here because it's a lot. So our exact answer, and I'm going to rewrite it, is is 2 times the log of 2 divided by the log of 1.03 plus 5. Now, that is a lot. So when you're putting in your calculator, I say do one step at a time. So what I say is start on the complete inside and work your way out. So in other words, we're going to start by putting that into your calculator. Then you'll add 5 to it because that's the next way out. Then you'll end with multiplying by 2. So start on the inside and work your way out because that's just order of operations. You always work with the innermost parentheses first, then the parentheses, then whatever operation's left over. So I'll do this together with you guys in the calculator. So I have log of 2 divided by log of 1.03. I want to hit enter. Then I'm going to hit plus 5. So it's inputting the previous answer, adding 5 to it, hit enter. And then finally, I'm going to hit times 2. So my answer is approximately 56.90. So again, start inside and work your way out when you're putting this in the calculator. Again, you could put all of that in your calculator, but you would have to be stupidly careful with those parentheses. All right, so if you're not confident in putting all the parentheses in the correct places, do it one step at a time. Yes, ma'am. Yes. So this is approximately 56.90. All right. So again, it's a lot, but it's not terrible. Now, the last thing we're going to talk about is how to apply it to the word problem. So this is coming back to what we talked about on Monday, all right, with the 2.2 word problems. Okay, so exponential growth, exponential decay. Because what we've been doing so far is that we're given the x value to plug in for x, and then we get the y. Well, now we know enough that we can solve for y. All right, so we're going to do some exponential growth and decay. And they were nice and they gave us the growth formula, which this is just the same thing as the one we're used to. So A is equal to P times 1 plus R to the T power. So let's start by writing out an equation. So a biologist is modeling the population of bats on a tropical island. When he first starts observing them, there are 104 bats. And he believes that the rate is growing at 3% per year. Now, we first want to write an equation for the number of bats, which we'll call B of t, as a function of the number of years t. So, remember, always start by figuring out what your variables are. So, A in this case is going to be B of t. What is P? Yes. Put your name on the board. You can go when Anna gets back. So, what's P? 104. Remember, P stands for principal, which is just our starting amount. What's my rate? 3%. But remember, I want it as a decimal. So what is this? 0.03. And we don't know what t is, so I'm going to leave it as t. So if I plug it into my formula, I get B of t is equal to 104 times 1 plus 0.03 raised to the t power. Now, I'm going to clean it up by evaluating the addition in the parentheses, which that's really easy. It's just B of t is equal to 104 times 1.03 to the t power. So this is our equation representing the growth of the bat population. All right. Now, we are then going to use that exact same equation to figure out algebraically the number of years it will take for a bat population to reach 200 bats. And we're going to round to the nearest year. So, where is 200 going to be placed into my function? Is it going to be going for B of t or for t? B of t, because it's the bat population, which is what B of t stands for. So my equation is going to look like 200 is equal to 104 times 1.03 to the t power. Now we can use what we have learned about solving with logs to solve this by hand. All right. Now, first off, is the base by itself? So the number connected to the exponent, is it by itself? Nothing's being added, subtracted, multiplied, or divided to it. The base is not 200. Look where the exponent is. The base is 1.03. So is it by itself?
It's not by itself.
It's not by itself because it's got that 104 being multiplied to it. So I need to get rid of that 104. How? Divide both sides by 104. So we cannot take the log of both sides yet until we get the base by itself. All right, so if anything you can take from that, just remember, don't take the log till the base is by itself. All right. So now I got 200 over 104 is equal to 1.03 to the t power. Now, since the base is by itself, I can take the log of both sides. So I'm going to take the log of 200 over 104 and the log of 1.03 to the t power. So this would be, if I write it all out, log of 200 over 104 is equal to log of 1.03 to the t. So what's my next step for solving? I gotta do what? I gotta take that t, bring it to be in front of this log. So I have log of 200 over 104 is equal to t log of 1.03. What's my last step? So how do I get the t by itself? Divide by the log of 1.03. So the exact answer will be t is equal to the log of 200 divided by 104 all over the log of 1.03. But we know that we need to round it to the nearest year anyway. So in my calculator, I'm going to put that in. So I have log of 200 divided by 104. And then I can close that parenthesis for that log. And then divide all of that by the log of 1.03. Close that parenthesis. So if I round that to the nearest year, how many years will have to go by? 22. So t is approximately 22 years. Now, guys, we've been doing a lot of this work, but let's say this is on the test and you are completely blanking, and even with your journal, you still don't remember how to do this. What can you always do? If you're solving any equation, what can you always do? What did I say is always going to be your friend in this class? Desmos. All right, I let you use Desmos on every last one of your tests. So if you don't remember how to do this, if you can get to the green equation, all you do is just set the left side equal to y and the right side equal to y, find the point of intersection, and use the x value. All right, just like we did when we were doing absolute value equations. All right, now I still want you to practice this method, but again, last resort, if you don't remember, use Desmos. Because especially on the EOC, they don't give a darn diddly if you show your work or not, as long as you get the correct answer. And that's the sad truth about it. All right. You're supposed to get as many as you can right. That's why I say Desmos your way out if you can. All right. So, one last thing that we're going to do. We're just going to do a, nah. All right. So, for the rest of class, you got a solid 35 minutes. You should now be able to finish that 2.4 Delta Math that I assigned 2 days ago. All right. So, the last two sections of that 2.4 Delta Math, you should be able to do now. Yeah. So there's no new Delta Math. It's the same old one, but you should be able to do it now. Yes. Yes. Yeah, just write your name on the board. Don't forget, you also have those 2 quizzes from yesterday that you need to get done. So, test corrections, I don't necessarily take class time for them, but you're more than welcome to do them during classwork time, or you can come after school and do them. It's just up to you. But how they work is the instructions. Well, give me one second. I need to stop this video.